it's 12.1, question 4E. Okay, so for 4E, is there any issue with 4E? No? Okay. So just a reminder that we should have a good practice, okay, to leave our answer in positive index form. Alright, so therefore it will be preferred to actually to answer as 1 over 4x to the power of 6 over 5. Okay, then for 5A, right? Okay, I thought that maybe just work it out along with you, okay, in case some of you actually don't know how to do. So for 5A, at this point, because we are limited by the kind of rules that we have, okay, if some of you have already studied your product rule, quotient rule, you may be able to apply it, okay, but at this point, with the beginner set of rules that we have, right, what we will do is to simplify this fraction, okay, so we can see this fraction in this manner. Right? So we put the denominator to each of the term that's on the numerator. Then we simplify it, so we will get 3x2 minus half plus x1 minus half minus x1 negative half. Okay? So we would get 3x or 3 over 2 okay, so simplified form will be this way. Okay, only in this form, then you are able to use your rules to actually go on differentiating it. So our dy over dx will be 3 times 3 over 2, x to the power 3 over 2 minus 1 plus half, x half minus 1 minus negative half, x negative half minus 1. Okay, then keeping to the practice of leaving our answer in positive index form. So for this first term, you may want to change it into your surd form or your radical form. Okay, then after that, this one you may also want to change it into this way. But for this, up to yourself. If you want to express in radical form, this will be how it looks like. Okay. Otherwise, will be x to the power 3 over 2. Right? Any questions? Struggle with question 7? Question 7? No? Okay, that's good news, I hope. Or maybe you already rectified that struggle. Okay, so we are looking at y equals to x minus 1, 2x plus times 2x plus 3 divided by x. We want to calculate the gradient, okay, of each curve at the given point, which is x equals to 2. So what we will do, okay, is that if you want to actually do something similar to what you did in 5A, okay, then what you will get is this. Am I right? This? No? How many of you think that is this? Irving? Correct? Okay, what took you so long? Okay, so no, alright, so this is not true. Okay, one counter example, if you think about your 6 over 5, 6 is 2 times 3, but we know that 2 over 5 times 3 over 5, that will give us 6 over 25. If you use calculator, you can verify using calculator, they're all numbers. So clearly this and this are not equal. Okay, therefore algebraically, you cannot actually say that this and this are equal. Okay, so what you needed to do, okay, because you cannot split up the fraction, right, just like how we did in 5a, what we had to do is to actually expand the numerator first. And get this. Okay, so expand numerator and simplify it. Then now we are actually saying that in the numerator we are actually, the terms are actually segregated by a plus or minus sign, which is something similar to 5a. So only in such form then we can split the fraction up in this manner and get this form. Okay. So notice that over here we are looking at y equals to all of this. Okay, my dy over dx is not in yet. Then dy over dx, we would be getting 2 plus 0 minus 3 negative 1 x negative 2. So for simplification, that's what you get. And at x equals to negative 2, the gradient would be 2 plus 3 over negative 2 squared, which is 2 and 3 over 4. Okay? Not a lot of chapter. I thought you're sitting here. Don't worry. Where's Joanne? Oh, Joanne is absent. What happened to them? Joanne and Bernice. Got what? Oh, okay. Alright, any questions? Okay, great. Now, last question that I want to touch on for this chapter 12.1 is question 11 of exercise 12.1. You're given the equation of the curve, which is a cubic one. Then the gradient of the curve at the point 316 is 20, and we want to find out the value of P and Q. Okay, so with this question, how would you want to go about starting it? What will your first step be? dy over dx, okay. So dy over dx, what do you get? Wait. Sorry? 3x squared plus P. That's all? Okay? You agree with this? Right, so P and Q are actually constants stated out in your textbook. So since P and Q are constants, and especially Q being a constant, when you differentiate it, it becomes 0. So this will be the derivative. Okay, and since we know that the gradient is 20, so what we will do is that at 316 itself. Okay, that means when x is equals to 3, our gradient will be 20. And that will allow us to actually find out the value of p. So p is -7. Okay. So finding the value of p is not an issue, since we know how to form the equation. But what about the value of q? Yes, sir. Use the equation, sub in the values. Can you elaborate more on how do I sub in the values? Sub in what values? Use this equation. So what do I replace? Okay, p with the -7. Then how does that help us to find q?
This is the coordinates are there. We say that 316. Then we submit the 3.
Okay, very good. So because this point itself is found on the curve, so we can substitute this point into the equation along with p to be -7. So having the x and y settled as well as the p, we can then find out what is the q. Okay, so 16 equals to 3 cubed plus -7, 3 plus q. And that would give us 6 plus q. So p is -7, q is 10. Any questions? Now, what about part 2? We want to find the coordinates of the other point on the curve where the gradient is 20. So, at this juncture, we at least know that the equation is actually this. Okay. How could we find out what is the coordinate of the other points? What would you do? Emily? Sub in the p. Okay. Okay, then I find x. Alright. Okay, so what everybody suggested is we find using the derivative, equate that to 20, we solve for the value of x. So x squared would be 9, x is 3 or -3. Okay? So how do we know which one is the other point? Amanda? Would 3 be the point, -3 be the point? Why? Okay, because 3 is the one that we have already found. Okay, so therefore we reject this one. Okay, so when x equals to -3, we can find out the value of y. And that would be 4. So the other point is -3, 4. Yep. Use the long division. How do you want to use the long division? What? This is a cubic one. But what is the y value? This one not 0, right? You understand what's wrong with your process? You're not solving this equation. Yeah, we're trying to find one that has the same gradient. Okay, we're not trying to find the intersection with the x-axis or anything. So there's no cubic equation for us to solve. Okay, so with that, right, 12.1 is done. Okay, and with finishing that homework, of course. No space already. Okay, so exercise 12.1, page 10, 11, question 4E, 4D, 5E, 6E, 6F, 8 and 9. Okay? So this one due on next week. Next week is even week. Monday. Okay. I first time see people will agree to a deadline so happily. So Monday Okay, next we are going to be looking at chain rule. Okay, so chain rule is a very useful tool that will help us to go about solving, or rather to go about differentiating, okay, equations or expressions that look like maybe 3x squared plus 7 to the power of 5. Okay, because currently, based on what we have, okay, in order to differentiate this, you will need to actually go about expanding it first. Okay, and that will definitely be a very tedious task. Okay, and in order to expand, I don't know if any of you remember, we have binomial theorem to know how to expand this. But can you imagine having to do binomial theorem and also differentiation in the same one question? Okay, so definitely a very difficult thing to do. And mathematicians are typically rather lazy. Okay, like shortcuts. So we have chain rule. Okay, so chain rule works rather similarly to how we go about doing our power rule. So if you recall, our power rule is about trying to differentiate things such as 7x to the power of 5. So in our power rule, to differentiate this, we get this. Okay? And to get this one, the whole process was that we bring down the power and power minus 1. Okay? So that we can get this. But now what about this? So it works similarly, but the difference is that there is this whole thing inside that is inside the brackets for the power of 5. So our chain rule so if I let y equals to 3x squared plus 7 to the power of 5, our chain rule will tell us that we will likewise bring down the power minus 1. Okay, but there is an additional step that we got to do, which is to differentiate the inside of the brackets. So 3x squared plus 7 itself got to be differentiated, and then you multiply it, so 9x, sorry, not 9, what am I doing? 6x, okay, plus 7 is 0, okay, so let me just intentionally put it down, okay, so bring down the power minus 1, alright, and then after that, this thing here, differentiate. Okay, so it's just one additional step, which is remember to differentiate the things inside the brackets, and that will be your chain rule. It is called a chain rule because it is something like one after another. Okay, so it's always outside then inside. So looking at try 6. to the power of 10. Okay, how should we go about differentiating this? Okay, what do you think? Maybe answer? dy over dx is equals to?
10 bracket 2x squared plus 3x to the power of 3.
Okay.
And times 4x
Yes.
plus 6.
Yes, very good. Okay. So a reminder also that this one keep. So it maintains and then there's a differentiation outside. Okay, so this one we cannot leave it like this, or rather actually we can, okay, just that sometimes maybe they want it in a certain form, so depending on the question itself, depending on what form, okay, so a habit that most people have is to arrange in increasing powers, okay, but that is just a habit and a good presentation, good practice itself, okay. So it doesn't make a difference because the answer still is the same. So just keep a lookout to how the question actually wants you to leave your answer in. Next. What if I have y equals to 1 over 5x minus 1 to the power of 3. Now that we have learned some rules already, intuitively, what would you do? Wait, what do you think you would do? When we have things like 1 over x cubed, what would you have done in our previous set of exercise? Sorry? Move it outwards, so I will get. Yep, so if I were to apply, extend that to this, what will I get? Okay, yeah, so 5x minus 1 to the power of negative 3. Right, so this would be what we would do if I had my question in this manner. So now that I have it in this manner, we can still apply our chain rule, okay, that we have just learned, even though the power is negative. Okay, so even if it's fraction, we can also do that. So bring down the power. Okay, so remember put dy over dx. Bring down power, keep, and then minus 1. And then differentiate 5x minus 1. In this case, it is important to simplify because we can take negative 3 and 5 to multiply with each other to get negative 15, 5x minus 1 to power negative 4, or we can leave our answer in positive index form, which is in this manner. We look at part B. If I square root 7x squared plus 6, what would you do first? Kaylee, what would you do first?
Change the square root to power.
Change the square root to power of half. Okay, then what would my derivative be? Half. Then 7x squared plus 6 to power negative half times 14x. Anything else? Okay. Right, is this answer okay? Sure, okay? Acceptable? Accept, then we why not acceptable?
70 is the
Oh, so this one you bring down. Okay, so I will write as 7x squared plus 6, like that. And then on top, 7x. So like this. Okay, so go practice positive index form. Contented with this answer? I don't know. Must ask, ma. Yeah. Okay. Emily, don't shake it. Then test, then you must answer what? Give test must answer, ma. If I give test, nobody answer, then I do test for what? Yes, Emily. The dy over dx, okay? So must have dy dx, otherwise cannot write it this way. No marks at all. Okay, next, I want you to practice, okay, your chain rule. Exercise 12.2 in your textbook, page 14. I want you to do question 1A, 1C, 1E, 2B, 2C, 2F. It is inevitable, you must really train yourself in this field. We got differentiation to last us for 4 chapters. Oh, okay, thank you. I just want to point out that for 4B, right, okay, it's something different in the sense that the question gave you y equals to something and then the variables used is r. So therefore, we cannot differentiate with respect to x because there's no x involved. So please take note that we should be looking at dy over dr. Okay, so earlier on I also made this mistake myself. So just keep that in mind about what is it that we are differentiating with respect to. Okay, for the rest of the questions, I'm just showing some variety in the presentation. So most of the time, I like to use that y equals to something. But you notice that I also show what if I do it in a different form of notation. Okay, so up to your personal preference and also up to dependent on the question itself, what has been given to you. Alright? Because if the question defines fx to be something, it doesn't make sense to write dy over dx because the question did not specify what is y. So then you should be talking about f prime x instead. Okay? If there is no issue regarding the questions here, okay, could we move on to question 5c? Okay. So in question 5c, you are given y equals to 1 over 3x minus 2 and y is equals to 1. We want to find out what is the dy over dx, okay, and also the gradient at the points given. The points, they didn't give you the full coordinates, they just tell you that the y coordinate is equals to 1. So with this, okay, what you first probably do is to change it into this form. Then after that, you differentiate. Okay, so upon differentiation, you will get this for your dy over dx. Then after that, the problem lies when we are given y equals to 1. Okay, clearly we cannot take y equals to 1 and substitute inside here to determine the gradient. So there are more steps that needs to be taken, and what would that step be, Alia? Okay, so we sub this in and then find out what is the x coordinate. Okay, so 1 is equals to 1 over 3x minus 2. So 3x minus 2 equals to 1. And coincidentally, x is equals to 1. Okay, so now that you found out the point itself is at 1, 1, so the gradient would then be dy over dx where x is equals to 1. Negative 3 over 3 times 1 minus 2 squared. And that is equals to negative 3. Okay, so the gradient is negative 3 at the point 1, 1. For question 6, Okay? At first glance, you may be thinking, why am I given this question? Okay, when you don't really have much rules yet. But if you look closer at the question itself, you may realize that it is something that you are definitely capable of doing. Okay, the reason is because the base itself is x plus 2 over here, and in this case it is x plus 2. So the base is actually the same. Alright, so I could convert the surd into a power of half using our indices law. We are looking at the powers adding up to each other, and that simplifies to 5 over 2. A reminder that usually our powers, we don't write it in mixed numbers. Okay, then we can proceed with our dy over dx. Okay, and we will get this as our derivative. In differentiating our x plus 2, we get a 1. So if you can see that it's a 1, you can do away with writing this 1 now. So you can save one step of writing. Okay, any questions? Do you have any lesson after this? No? Okay, I still have 2 more questions, but I'll just end here for today. Okay? Save your brain cells. Just go home, do your homework. Okay, then after next week we will continue. And then after that I'll introduce to you product rule and quotient rule the next lesson.